Hello, welcome to this presentation called Maximizing BIM Potential for AEC Projects. My name is Nathan Pangabian. My supervisor is Dr. Estella. I thank Dr. Estella for her guidance in helping me to do this presentation and proposed project. Imagine a large high-stake construction project being completed on time with no cost overruns and delays, seamlessly moving from stage to stage from schematic to its finishing. If you look at the slide on the right there, it's Perth Arena. It was 548 million over budget, 3 times the budget and 3 years late. Obviously there's something wrong with the process and something's got to be done. According to McKinsey Global Institute, large projects across asset classes typically take 20% longer to finish than scheduled and are up to 80% over budget. The whole industry is overdue for a disruption. One of the main solutions to the construction industry problem is to integrate its process. The technology of integration and digitation is BIM, Building Information Modeling. Project aim: to propose an optimization summation of BIM technology and process for AEC projects for the purpose of increasing productivity and reducing costs. The objectives: identify key factors that prevent and delay the utilization of BIM in the industry, especially for AEC firms. Investigate erroneous implementation of BIM technology and process by AEC firms, and propose methodology to optimize BIM implementation by integrated project delivery, or IPD. Provide proof of concept, which I will explain later on. To better understand the proposal, conceptual diagram can help explain the process of construction industry inefficiencies that can be greatly reduced by the technology called BIM. The proposal will look at 2 issues: slow adoption and erroneous implementation. Slow adoption may be greatly reduced or eradicated by client and government drive and a paradigm shift within the industry. They must be presented with costing and productivity benefits such as EVM, Earned Value Management. Next, we will look at erroneous implementation. The solution will be IPD in the form of BIM interoperability and cloud computing. EVM will be shown on a system called 5D BIM. 5D BIM is linked to BIM interoperability and cloud computing, and EVM is also a part of IPD, Integrated Project Delivery. Key factors of BIM adoption delay. First is uncertain return on investment, or ROI. Second, industry resistance to change. Third, lack of demand and cost of investment. Erroneous implementation of BIM process and technology. So based on the literature, I've looked at the problems identified as interoperable problems, then non-collaboration process, another one is contractual issues, and another one is lack of integration. Integrated project delivery. Integrated project delivery is pretty much a solution to the current process fragments. As shown on the slide there, it looks fairly chaotic, and if it looks chaotic, it probably is. This explains a lot about the inefficiencies in the construction industry. With IPD, the implementation of construction will be less fragmented and more coordinated. 5D BIM. 5D BIM is pretty much an intelligent linking of individual components within the model with schedule. With the schedules will be time, then cost-related information. 5D BIM is a 3D model of assemblies of components within an estimating database. Another key benefit is 5D BIM reduces 50 to 80% of the time needed cost estimate due to the automation and integrating nature of 5D BIM. Cloud BIM integration. NIST describes cloud computing as convenient, on-demand network access to shared pool of configurable computing resources that can be rapidly provisioned and released with minimal management effort or service provider interaction. Proof of concept simulation diagram. The proposal will simulate the automation process of BIM integrating project delivery, starting from schematic stage, and we have 3D Revit models. From the 3D models, we extract intelligent information using external plugins. These infos will be costing, project scheduling, design information for analysis. Now, architectural updates, consultant updates, clash detection will be performed to move on to the next stage, which is the tender stage. And of course, the 3D Revit models will be updated, and costing is updated and finalized, schedule updated, design information updated. All of these are automated. Final updates of architectural consultants will be done, and then final clash detection will be performed at Navisworks for construction stage. And the construction stage, schedule a final, design information final, and no more cost changes because previously it was already done and approved. Model will be uploaded and updated to a cloud server, and the collaborative simulation performed on Cloud BIM. We use 3 different Revit models of the building: architectural, structural, MEP. For clash detection, the models will be integrated. We can then also derive parametric information such as costing, etc. For cloud collaboration, the models are stored in a cloud server using A360. Anyone with access can review the model and be an active participant in a collaborative method. The proposed project will have questions for BIM implementers in the industry. The purpose for the question is to investigate how RPD and BIM delivery, to investigate how BIM implementation correlate with theoretical result, help better understand real world and theoretical correlation. The questionnaires will be delivered to the candidates in Google Form format. I hope the presentation has been beneficial. I thank you for your attention. Thank you.